What are the requirements for the test setup of testing power quality analyzers? First of all, of course, we need 3 voltage and 3 current outputs. Then we need a preferably high accuracy, especially when it comes to testing of Class A power quality instruments. And of course, we need a software that, together with the test setup, can simulate and output the correct power quality phenomena. And the last point is to use a time synchronization and also to allow the time-triggered start of tests. We strictly recommend to use so-called test templates to test power quality analyzers, because if you want to start from scratch, you have to have deep knowledge of the relevant standards, which I mentioned before. But the test templates that provide a predefined test procedure that allow you to start a test with one click, so you don't need to have this deep knowledge. They also explain the test procedure, and also the test signal, or which settings have to be made for the test set or for the test object. Then they easily can be adapted to the nominal voltage or to the frequency that particular power quality meter has. And also, and this is very important for testing power quality analyzers, is that they contain guidance and help for the assessment of the tests. Because others than in protection testing, you don't have a binary contact just for trip or no trip, but you have to do a manual assessment, and this is somehow a little bit complicated, so additional guidance can be very helpful. All of what we heard before is just valid for the type and acceptance test according to the IEC standard 61430. But on the other hand, there is no standard or best practice for doing a field test. Even it could be very important to check the accuracy of the power quality instrument in regular time intervals. So what we decided is to provide the field testing template as well, and this is based on the type test template, but it is with a reduced test duration and complexity. If we take again the example from the beginning for the magnitude of supply voltage test, we defined several criteria to exclude tests from the type test which we don't want to use in a field test. These criteria are, for example, that we don't want to check the measurement method, we don't want to do tests with predictable result or without practical relevance, and of course we cannot do any tests in the field that are just not applicable because of several reasons. For example, you cannot check with a certain surrounding temperature because you cannot influence it. And because of this criteria, the first and the third group of these subchapters of the magnitude of supply voltage tests are already excluded, and we are just focusing on the second subchapter, which is related to the measurement uncertainty over the full measuring range. Excluding these tests from the field test leads to 2 basic concepts for a field test. And one concept is very basic and the other one is a little bit advanced. The main difference between them is, for the basic field test you don't need the time synchronization. For the advanced field test you still need time synchronization, and at the field test it's based just on display reading of the power quality instrument. And for the advanced field test you have to use additional software or like a web HMI of the power quality instrument, so there's additional effort to assess the tests. Both of them have a very short duration of about 1 to 2 hours, which is very less compared to the 2 weeks test duration of the complete type test. To have a short glimpse on the coverage of the 2 test concepts, what do they contain of the IEC 62586-2, I think the main differences between them is that the advanced field test contains tests for flicker as well as interharmonics for current and voltage, and the basic field test does not contain them. To have a short summary, when it comes to testing of power quality analyzers, you can either do a type test or a field test, and the type test has a target to do a certification or to do an acceptance test, which is also standardized in the IEC 61430, which has a high complexity and a very long duration. It is mostly done by manufacturers or very big utilities. And the field testing concept is more for like commissioning or routine testing, as well as as a calibration test. There's no standard or best practice. The complexity is very low and it takes just up to 2 hours to do the whole test. This target group, I would say, is like also for utilities, but more for industry or also end users.